Welcome to our channel. Watch the video until the end. Leave a like, and subscribe to the channel to support us.
Every 22 minutes, a mysterious signal interrupts the silence of the universe. Astronomers are puzzled because they have been receiving this signal for 35 years, and so far, its true origin has remained a mystery. This signal could be a completely new cosmic phenomenon, or it might be a message whose algorithm and true meaning we have not yet understood. Where does this mysterious signal come from?
Why is it so different from all other sounds and signals in space?
Have scientists finally found a plausible explanation? Signals in space are actually not uncommon, but this signal, which we have received with surprising regularity for 35 years, is different from any other sound in the universe. While most cosmic signals tend to be random or short-lived, this signal has proven to be unusually stable and constant over an extraordinarily long period of time. Cosmic signals can come from a wide range of astronomical phenomena, including stars, galaxies, quasars, and neutron stars.
Pulsars are a class of especially fast-spinning neutron stars that emit high-energy radiation. These beams travel through space like the signals of a lighthouse and sound a bit like the regular ticking of a precise clock. Signals from quasars or active galactic nuclei are more like noise. They sometimes have sharp peaks or are sometimes prolonged if they come from slower, large-scale processes in the universe. The latest phenomenon in this series of already known and well-studied cosmic signals are the fast radio bursts, FRB. These brief and extremely intense signals last only milliseconds. Their origin has not yet been completely clarified, but they probably also come from massive radiation sources like quasars or gamma-ray bursts. FRBs usually sound only once or with few repetitions and seem like sudden and bright screams in the cosmic silence before returning quickly to silence. The signal that has captured researchers' attention for 35 years does not fit into any of these categories. Like a tireless cosmic metronome, it sends a mysterious message every 22 minutes. Each signal consists of individual pulses that last between 30 seconds and 5 minutes. These pulses always occur at exact intervals of 21 minutes and 58 seconds and last about 6.5 minutes. Despite the variability of the individual pulses, this source shows a surprising stability, thanks to the exact intervals between individual signals and the continuity over 35 years. While the frequency would be consistent with a pulsar, the unusual length of the pauses between signals and the consistency of the pattern over the decades contradict the behavior of a typical pulsar, whose signals usually occur at much shorter and more regular intervals and at a higher frequency. It's a message we don't understand. Researchers were amazed when they first heard this signal in 1988. It was clearly different from the usual chaotic noise of space and caused a small sensation. When such irregularities are noted, scientists immediately seek all possible explanations. But in the case of the signal, named GPMJ 183910, they failed. The signal was unique in 1988. News of an unexplained signal from the depths of space made headlines. Discoveries like this always make us think of the long-awaited signal from other creatures. Many people who read the headline at the time hoped that it was the first evidence of extraterrestrials and perhaps the start of friendly contact with other forms of life in space. However, there has been no confirmation of first contact with alien life forms, and scientists have struggled to make sense of the signal. Normal radio signals sound like either random or very specific periodic patterns, and this was certainly true for the signal in question. However, all known decoding methods on Earth have been unable to extract a deeper meaning from the signal. Naturally, we can never rule out the possibility that another species uses completely different frequencies and algorithms to send messages in space and that we simply cannot decode such messages. It is also worth noting that our messages, which we send into space via radio waves, have never received a response. Statistics have shown that there could be about 30 intelligent civilizations in the Milky Way alone. GPMJ 13910, who is sending the signal?
Have you ever thought about who might respond if you sent signals packaged as random greetings into the universe? The first signal of this kind was sent from the Arecibo Observatory in 1974. Subsequently, the first attempts to contact extraterrestrials via radio signals developed into SETI, the Organization for the Search for Extraterrestrial Intelligences. This scientific organization aims to use radio astronomy to search for signs of intelligent life beyond Earth. To this end, SETI scientists mainly listen to electromagnetic signals that may have been emitted by extraterrestrial civilizations. Since the 1960s, scientists have developed various methods and technologies to filter out potential messages or signals of extraterrestrial intelligence from the vast noise of the universe. Experts call such algorithms techno-signals, which usually differ significantly from natural signals due to their frequency repetition and a certain complexity of frequencies. Some critics believe that the search for extraterrestrial signals is akin to looking for a needle in a haystack, given the vast size of the universe. Considering the sizes and distances between star systems and the many billions of stars in the Milky Way alone, it might indeed seem impossible to find receptive ears or receive other signals. The fact that we are able to capture signals from cosmic events thousands of light-years away gives us hope. However, critics present another argument that we should at least consider carefully. We can never know who receives the messages we send carelessly into space. We cannot assume that all beings in the universe, if they exist, are friendly. It sounds scary, yet it's true. Now we must consider for a moment whether it is a sin that SETI has not yet found a single signal of clear technological origin or if it is a blessing. In all this time, about 5 signals have been candidates for first contact, at least for a while. GPMJ 183910 might be one of these exceptions, but in almost all cases, natural explanations have been found for the signals. It is a celestial body that emits the mysterious signals. Although the mystery of the signal GPMJ 183910 remains unresolved. It has been demonstrated that most signals that travel long distances in space are emitted by magnetars, pulsars, or neutron stars. In 2022, Australian researchers discovered a particularly unusual magnetar about 15,000 light-years from Earth. This neutron star rotates very slowly, indicating that it is very old or represents some other anomaly. Normally, a magnetar rotates at a speed of several revolutions per second, but this strange star has extended its rotation speed to a full 22 minutes. It is not yet known why a magnetar would change its behavior in this way. It could be a sign of age, but normally old magnetars with such slowed rotation rates no longer send signals. Researchers know a death line for the rotation rate, below which a neutron star loses its radiation and ability to send pulsating or beeping signals into space. However, this neutron star rotates slowly and sends signals into space with remarkable frequency. It was discovered by a team of scientists from Curtin University, using the Murchison Wide Field Array in Western Australia. Typically, researchers identify objects like this by analyzing electromagnetic waves. Magnetars and pulsars can be identified in the vastness of the universe only by their radiation and acoustic signals, as they no longer emit light when they burn out. Radio astronomers specialize in objects like these. They study phenomena like pulsars or fast radio bursts with large radio telescopes. Facilities such as Arecibo in Puerto Rico and the fast, 500-meter aperture spherical telescope in China use gigantic dishes to capture radio waves instead of optical signals. The FAST telescope, often jokingly called Sky Eye, has an impressive diameter of 500 meters and is the largest radio telescope, receiving countless signals from space 24 hours a day. With a single dish, today's radio astronomers no longer listen to space with their ears. Most of the signals coming from space are not even audible to the human ear. High-performance computers filter the signals, check some audio tracks, compare them with known data, and signal all the signals that are obvious or that cannot be assigned. This is how the Australian researchers noticed the signal that repeats every 22 minutes. It is about the magnetar that has been transmitting for 35 years. In their publication in the scientific journal, Science, the Australian researchers related the newly discovered regular signal to a much older discovery. The article talks again about a mysterious signal received for the first time in the late 1980s and never truly decoded. The researchers are 100% sure that this signal and the magnetar they discovered are the same thing. The magnetar was located in the constellation of Scutum, very close to the much better-known constellation of Sagittarius. In their study, the scientists compared the repetition rates of neutron stars, which usually repeat in a few minutes or even seconds. The long intervals at which GPMJ 183910 emits signals turned out to be unusual. Only one other similar signal was noted about a year and a half before the discovery of the magnetar in the constellation of Scutum. The same research team had already discovered a celestial body that emitted signals every 18 minutes. The phenomenon may therefore occur more frequently than previously hypothesized. The radio signals in neutron stars derive from the rotation of the celestial body and its magnetic field. Magnetars are special forms of neutron stars endowed with an exceptionally strong magnetic field. The field is about 2 quadrillion times stronger than Earth's magnetic field and 20 trillion times stronger than the magnetic field that retains a common paperclip. These magnetic monsters emit unimaginable sizes of X-rays and gamma spectra, accompanied by impressive stellar shocks on their surface. Magnetars can develop forces comparable to the powerful primordial force that formed our planet at its dawn. Neutron stars are formed when a star explodes in a supernova at the end of its life, and what remains can be a black hole, a normal neutron star, or special forms like pulsars or magnetars. Normally, magnetars are often active only for months or a few years, but the fact that such an object has been emitting audible signals with an active rotation rate for more than 35 years is highly unusual. Scientists now want to study this mysterious object more thoroughly and hope to gain further fundamental information about the nature of neutron stars. The object has been given the provisional classification of an ultra-long-period magnetar, pending further clarification on the phenomenon.
Click subscribe, because more exciting videos are coming soon.